Okay, so we have a topic of time value of money. I just thought that I should make a video on it. And for some guys, for some students, that if you miss the lecture or if you find difficulty in finding this topic hard, you can find solutions here or you can revise your lecture here. So basically, what was the time value of money was, as my previous and online tutorials I've seen that the value of the money grows with time. I would just say value of money grows with time. Graphically, if I say this is the time and this is the value. So it is like this. Your value grows with the time graphically. Right. How come this possible? Let's say if we have $100, I want to invest in the account and the bank pays you 10% interest, then after 1 year how much they're gonna be, and after 2 years how much it's gonna be. So let's say if I take an example of this $100, I will say that today the value of $100 is $100. So present value is $100. Interest rate that the bank is paying is 10%. N is, let's say, is 1 year. Okay, and find the future value, that after 1 year what will be the value. So in order to get the answer right, what we're gonna do is take the $100 plus 100 into 10% of 100, mean to say 100 plus 100 into 0.1. Okay, we can convert 10% into 0.1, mean to say 100 plus 110 is 10 is equal to 110. But again, if I want to see what gonna be the balance after 2 years, if we don't get the money out of the bank account, if we don't withdraw money, then obviously at the end of 1 year we would have a balance of 110. Same logic if apply, that after 2 years how much it gonna be. So it's like 110 plus 110 into 10% implies 110 plus 110.1 implies 110. 10 is 11 implies 121. Again, if I want to see what gonna happen in 3 years time, so I would have 121 rupees dollars. Same logic, 121 plus 121 ka 10% implies 121 plus 121 into 0.1 implies 121 plus this gonna be 12.1, I guess, is equal to 133.1. So this is the answer. Minor mistakes in the calculation, don't get me wrong, but there could be minor mistake in the calculation because I'm not using the calculator thingy like this. So this is the approach. Another way of doing this is using a timeline. So what a timeline is? Timeline is just a simple straight line with time starting at 0, today, now, 1 year, 2 year, and 3 year. Okay, in fact, if I just make a bigger line to make this clear, make a bigger line to just make things clear. So what I done is time 0, time 1, time 2 and 3. So what's gonna happen is $100 invested today. After 1 year, I can say, okay, let's do it another way. This approach is limited approach, I mean time consuming approach. Another approach I can use is, for this part, 100 into 1.1. What do you say? That could be possible, because why? If we take 100 and 100 common from this side, I'm gonna having 100 into 1 plus 0.1 goes to 100 into 1.1. So you can keep track of this. I mean, doing the shortcut is, this relationship can be presented by this amount. In the same way, we can do this 110 into 1.1, 121 into 1.1. In the same way, okay? You can do the math by yourself. You can take the common out, 110 out goes to 110 into 1 plus 0.1 is equal to 110 into 1.1. So this is a shortcut approach, and we're gonna be using this approach. We will not be using this kind of things, right? So if I use the timeline, after 1 year, what is gonna be 100 into 1.1. Okay. Let's do it another way. I just don't want to make it clear to you that using different color, in fact actually using different color, 1.1. okay, after after 2 years, what is gonna be? It's gonna be like which color I would choose? Let the answer is 110. We know that. If I say 1.1 and I use the same logic, that the answer is 110. So you can see how it goes. And if I use the same thing, is 121 into so what I'm doing is, after every year I'm just multiplying 1.1 and 1.1 to the preceding amount. Alternatively, I can see that I can also write this equation, simplify this equation as this, that this is 100 into 1.1. This 110 is actually, it can be represented by this. So 100 into 1.1 1.1, the same factor, and if I see this amount altogether can be written as 100 into 1.1 into 1.1 and again 1.1. So this factor 1.1 is added every year. So in short, I can say, I can just say that I can represent this figure as I don't want to use I can use this color here. I can say This is 100 into, this is 100 into 1.1. I can say this is 100 into 1.1 की power 2, and I can say this is 100 into 1.1 की power 3. So you see how the pattern is. Every year I'm just adding the powers up. I'm just adding the power here is 1, power here is 2, power here is 3. So if I keep on doing so, I just need to change the powers. I hope you can grasp this idea. I can let me just scroll down a little bit so I can. So I can say I can devise a formula through this, which is I'm just adding the powers during the timeline. I'm doing it again, so you can see yourself that today it's 0. After 1 year it is 2, 1, 2 and 3. So today is the present value. After 1 year it gonna be 100 into 1.1. After 2 year it gonna be 100 into 1.1 की power 2, and after 3 years it gonna be 1.1 की power 3. And if I keep doing so, let's say it is 10 years, so I can find out the value after 10 years like this. What do you say? Okay, so that's done. So using the same logic, I can say I can devise a formula using this logic that future value is given by present value into 1 plus I, the interest rate, and the power goes to n, where present value is equal to present value, future value is equal to future value, I is the interest rate, and what you say n is number of years for now, but in future I'm gonna say it's periods. There is some reason for that. So you can say that the formula is very simple, it's very logical and quick to remember. It is very generic formula, and using the same formula I can anticipate, I can produce different type of results. For example, if I want to know the future value, I need to know 1, 2 and these 3 things. If I want to draft the equation for the present value, I can just simply divide 1 plus I by n is equal to present value. Take this number down, okay, divide कर दें इसके साथ तो present value आ जाएगी. In the same way, I can derive equations for I and I can derive equations for n. Okay, do it yourself. Okay, whatever the techniques you can using, but you can do it yourself, draw it yourself, drive it yourself, explore these problems. So this is one type of question. Is the other type is given the future value, find present value. So how are you going to do it? Let's say one, two, and 3 times 0 So let's say at this point the amount is 133.1. Find the present value. So we know the number of years, how many number of years we are, we know the interest rate. So we have the present value as future value divided by 1 plus I is power n, and in this problem we have future value is 123.1 divided by 1 plus 0.1 raised to the power 3. Now how would you say that is 3 years? Because you say 1 year, 2 year, 3 years. So you have to go backward. I would say count backward. Just you have to erase that. Those are count backward, right? So in order to get the future value, we count forward, count forward, to find value, and in order to get the present value we count backward. So these two cases are given, so you can just easily do it, practice yourself, get the concepts done and see how it goes.